Hi there everybody, today we're going to look at a bunch of vector problems, kind of definitely aimed at higher GCSE in terms of obviously the understanding of this, so hopefully after today's lesson you'll feel a little bit more confident with it. So let's have a look. So first of all, okay, a vector has a magnitude and direction, alright, if you weren't sure. If two vectors have the same magnitude and direction, they are the same, okay, even if they are positioned in a different place. Alright, so a vector, it just basically has magnitude direction, but of course it doesn't have to be next to each other, but essentially it's all about basically a movement from one place to another, so where that's positioned makes no difference. Alright, so as long as it has the same magnitude and direction, they're the same. Okay, if a vector goes in the opposite direction, it's negative, and therefore you should be able to apply that to this. Right, so expressed in terms of A and B, AE, FH and AI. Alright, so I'm going to try and walk you through this as best as I can. So first of all, AE, so AE goes from here to here. Alright, so when we're doing vectors, what we're looking to do is the movement from one place to the other, and given essentially A and B. So just before I kind of begin, if this bit here is A, then this bit here is A. If this bit here is B, then this bit here is B, and that's B, that's B, that's B, that's B, that's A, that's A. You know, they're all basically, all the little horizontal parts are A, and all the diagonal upwards are B's, essentially. Alright, so if I'm going from A to E, now if I go along there, that's A, and then I'm going to add a B. So it'll be A plus B. Okay? Alright, so if I move this one along, you'll probably see, so I've got this one here, AD and DE, but DE is the same as that one. Alright, so it's A plus B. Okay? So that's AE. FH, so I'm going from this one to this one. Well, I suppose it's the same idea, but I'm going to go along that one. That's going to be A, but I would need to go down that one. All right, so that's going to be the opposite direction of B, so it's going to be minus B. So it's going to be A minus B. All right, so let's have a look. So that one's going to go up there, and that one's going to go up there. But of course, it's going the opposite direction of B, so it's going to be A minus B. Right, AI is the one that goes from here right to the top. Well, I've got a few going on here, so I've got quite a few A's. So I've got that one all the way up there and that one up there. So if I'm going to go B and another B, and then an A and another A, so I'm going to have two B's and two A's, or 2A plus 2B. All right. So that is vectors in relation to the idea of thinking one's the same as the other. Okay, that's quite important. And of course, from there, it's about using that information. Right. Sometimes though, you might be given a point which is either a fraction along a line or potentially a ratio along a line. All right, and that comes up quite a bit. All right, so you've been told to start with CD, this one at the bottom, is 3 lots of AB. All right, it kind of says up here, and it wants you to find AC. All right, well, if to find AC, I cannot go down here because I don't know what it is, but I can go along here, down here, and then back. All right, because I now know what CD is. CD is 3 lots of this, so this is 3A in that direction. All right, so I've written that on the board. All this you can see it there. So CD equals 3 lots of AB, and then we're going to work backwards, not backwards. Well, along here, down here, and along there. So I'm going to have A plus B minus 3A. All right, so A plus B minus 3A, and simplifying that, that's going to give me minus 2A and plus B, or B minus 2A. Okay, so there you go. That is AC. Okay, that one there, by going around the houses. Right, so this is the bit that we were talking about at the beginning. AM, here we go, AM equals MC. All right, so we split that in half. CN here is equal to 2 lots of NB. All right, so that bit there is twice that distance. AC is equal to A, so all that is A. And BC, that direction, is B. Okay, and I want to find MN. All right. Right, before I go into MN, I need to figure out what MC is, and then from there, CN. Okay, so let's kind of break that down. So MC, here we go, is half AC, because it kind of said they were both the same. Right, so if all that is A, then MC is a half A. Right, there you go, half A. If CN, remember the BC is, BC is this direction, isn't it? BC is that direction. So CB is minus B. And because this is CN is equal to 2 of these, all right, so that means it splits into 3, so 2 parts and 1 part, all right, so that means this is 2/3 along here, all right, so what we've got is CB, I'm saying it again, CB is minus B, but it's 2/3, so CN is 2/3 of that, all right, so CN is 2/3 CB, so it equals minus 2/3 B, all right, so that's what I was talking about. All right, so CN is minus 2/3 B. So MN is going to be this one and this one together. So bring those together, it's going to be half A minus 2/3 B. All right, so it can be a little bit awkward. All right, so what you've got to do, and you can see it all here from kind of the notation kind of written, is kind of writing everything down so you can not lose gaps and stuff. And it's a little bit of going back and forth, back and forth, back and forth, which is what I was doing. But of course, that's what you may need to do to make sure you don't make mistakes on it, okay? All right, so please go to maths-school.co.uk. There's a bunch of questions on there for you to obviously have a practice at. And of course, you can revisit this video if you feel you need to. Thanks for listening.